Okay, we are on AP Exam Practice 3, correct? And we are on the free response. So we are looking at free response number 4. I wrote A down because we talked about A previously. A was the derivative. So this was the final form of the derivative I gave. And officially, when you give this derivative, yes, you would need to put this X restriction on here. Because the original problem was restricted for values between -5 to 5, which means the derivative would be restricted for values between -5 and 5. You will notice, and I think this is what I mentioned at the bell maybe when we finished this, whatever day that was. Notice I don't have equal to's on here, do I? And that's because if this is equal to 5, what happens when you put 5 in on the denominator? You get a 0 in the denominator, and that's not okay. So that is why that is what it is. B, write an equation for the line tangent to the graph of f at x equals -3. So, when you need to write an equation for a line,
well, we're going to need a slope.
We're going to need a slope, and you need a point, right? And this slope and this point have to happen at -3. X equals -3, yes? So, it doesn't really matter which we do first here. How do you find the point at -3?
Just plug in -3 to the function, right?
Plug in -3 to the function. So let's plug in -3 to the function. The original function. So keep in mind, they didn't tell me f of x again, but you go back to part A, right? So the original function being the square root of 25 minus x squared. So we're going to do the square root of 25 minus -3 squared. Do some math. 25 minus 9, 16. The square root of 16 is 4. So what we know right now, in the original function, when x equals -3, the y value is 4. Or in other words, what is this point? -3 point. -3, 4. So our point we're going to be at is -3, 4. Besides a point, we also need a slope. How do we find slope in calculus world? The derivative. So we need to find the derivative evaluated officially at -3. Do we already have the derivative? We certainly do. This is how free response problems work. Okay? So I'm going to do the negative of -3 over the square root of 25 minus -3 squared. Negative of -3 is +3 over 25 minus 9 is 16. The square root of 16 is 4, if you will. Mainly because I just did that math on the point, didn't I? So our slope is 3/4. What did they want? An equation. An equation for the line. What would you like me to write?
Well, I was going to say point slope form because we have a point and slope, right?
Okay. So point slope form would be y minus 4 equals 3/4 times x minus -3. Did they say what form we had to put this in? No. Ross can stop here if he wants. Okay. Other equivalent forms.
Slope intercept. Then you'd have to find the intercept. Right?
Slope it, well, you could just work from here though. So other equivalent forms, one would be if it's -4, we can add the 4 to the other side. So you might see 3/4 times x plus 3 and then a plus 4 on the other side. I know Mark and Verge, the two that always, do the AP Calc videos and stuff. Mark really likes this form. Whatever. The other thing would be to take it over to slope-intercept form, which at that point, what? 3/4 x plus, what would you be doing? 9/4 plus 4. So 9/4 plus 16/4, so 25/4. Any of those work. You don't have to have all of them. Any of them work.
I just came from the bathroom and found these on the sink. Were these the ones that you had to open them?
The writing looks the same.
Do you know
But
who they belong to?
No, I never figured that out. Are the ones? No, because I left them down there.
Oh, they were in the bathroom.
Someone can't keep hold of them. I just leave them back in the bathroom.
Okay.
I don't know.
Leave them back in the bathroom. What was that?
Oh, they were note cards that I found in the hallway earlier after homeroom. And it was like Frederick Douglass or something. And so I asked like Mr. Stanley and Mr. Summers, and they both thought it'd be Mr. Wilson. But I mean, it's like a whole set of note cards about Frederick Douglass, Thurgood Marshall, and like a whole. And they said probably 8th grade. But it was weird because I'm like, someone's gonna want those. So now someone's picked them up and moved them to the bathroom. Who knows? Okay, random. I know. Okay, any three of these forms work, right? Doesn't matter which. Any equivalent form works. Back to the whole idea of AP as long as it's equivalent. So the smart thing, if you use this, would be stop here, because if you continue going, you might make a mistake, and then you don't get the full thing. Okay? Okay. C. I have to go to another screen. Let's talk C. We've talked about this lately. Let's see. Oh man, Ethan's not here. He's gonna complain. I can't. Ethan, are you hearing me? There's piecewise here. Okay. Let G be the function defined by. And notice there are two pieces, right? Is G continuous at x equals -3? Use the definition of continuity to explain your answer. What have we talked about in order for something to be continuous?
Left-hand limit has to equal the right-hand limit.
And?
And it has to exist at that point.
Okay, it has to equal at that point. So the limit from the left has to equal the limit from the right, has to equal the point right there. So, yes, we have to talk about limits. So, I'm going to say the limit as x approaches, what number are we talking about? -3 from the left. Okay, I'm going to start with the left. Oh, I should not have written that yet. Okay, as we approach -3 from the left, according to our piecewise, so pretend I didn't write that yet. According to our piecewise, what is the function on the left of -5? Excuse me, the left of -3. And that's the piece that is -5 to -3, correct? Which is defined as f of x. Now, what is f of x? Because that's what I'm going to have to talk about. So the limit as x approaches -3 from the left. What is f of x? Okay, the original function named back in part A, square root of 25 minus x squared. And what does that limit equal? You put in -3, 25 minus 9, 16. The square root of 16 is 4. So the limit from the left equals 4. Are we good there?
Yes.
Okay, now I'm going to look at the limit as x approaches -3 from the right. What is the right-hand piece of -3? And according to our piecewise g of x function, that is x plus 7. So what is the limit as x approaches -3 of x plus 7? Yeah, -3 plus 7, which is 4. So at this point, because the limit from the left and the limit from the right equal -3, one thing we can comment is thus the limit as x approaches -3 of g of x is equal to 4. And when I wrote it just now, I said the limit as x approaches 3. I didn't put the left or the right on there, did I? Because we've examined both sides, and this limit does equal 4. So we're good from the limits.
Would it still be -3, just from both sides, or?
It would be. Did I left that? Yeah. -3 carries on through. Don't let me leave that off. Now, the one thing we need to know is what is g of -3? Well, how do we find g of -3? I'm going to take that. G of -3 means I take -3 and put it into g. Well, g is that piecewise function, right? Which portion do I put it into? Where is -3 defined? Is it defined for f of x, or is it defined for x plus 7? It's defined for f of x, right? Because according to this, that's where the equal to part is, right? So when I say what's g of -3, I really have to find what's f of -3. Well, what's f of -3? Square root of 25 minus -3 squared, which, hey, guess what? Is 4 for about the bazillionth time in this one problem. Seems like it at least. So, is g continuous?
Yes.
Yes. So, I can say here that the limit as x approaches -3 of g of x equals g of -3. Therefore, g is continuous at x equals -3. Yes, you would be expected to write some words on this problem. Okay? Showing your work that the limit from the left is 4, the limit from the right is 4, and the function evaluated itself is 4. That's the work. Stating that the limit is equal to the limit from the left, the limit from the right are equal, the limit is equal to the point, therefore it's continuous.
I remember that was a big thing in physics where you have to do the math and then explain why it made sense.
You need to put, open-ended questions for your response. You need to put the words. Now, real quick on D. At the time, I don't know, have you guys had this for like a month or more now? It seems probably, unfortunately.
I remember
it's ridiculous.
I did this was for one of the e-learning days, right?
Yeah. Okay. Note, at the time, we had not covered the process for Part D without a calculator. Please use a calculator to complete Part D at the time. Have you already done that?
Yes.
Okay. We have since officially done that because you could do a U substitution here. But at this point, hey, guess what? Just do it on the calculator. Because I am struggling to get this done. So, get me an answer via calculator on Part D. Okay. Somehow this week, we have lessons all the rest of the week. Somehow this week, we're going to have to figure out a way to get these AP practices filled in or turned in. So,
all I have to do is go back to the
yeah.
Yeah.
As part of your homework or sometime, figure out in AP exam practice 3 and 4, what do you still need info on? Or are they ready to turn it? Okay? Know that knowledge, not just I don't know, I think I just need this. Know it.
Have it. No.
Like, no, what do I need from Mrs. Sargent?
Be ready.
Yep.
All right. Bye, Miss Sargent.
Bye.
Bye.